Welcome. Our senior design project is to design a RISC-V processor. In our group is John Kallela, Osbijorano, Alex Riveron, Birain Itor, and Jim Yuen. Background of our project. RISC-V is a new open source instruction set being adopted by industry. We plan to use RISC-V as a framework to enable us to design processors, compilers, and operating systems. RISC-V gives us the power to build a fully functional system, and it's simple enough to run at high clock rates. Part of how we got the idea is from last year's Capstone. Last year there was a group which built a RISC-V IDE and simulator that ran on any PC. We plan to go further by describing a processor in HDL and loading it onto an FPGA.
Here are some technical highlights from our project. It has two major components. The first is a custom 64-bit single-thread RISC-V processor design loaded onto an FPGA. The second is a compiler that generates machine code for our processor. We also have some stretch goals, such as making an operating system to run on the processor that includes things like process scheduling, a file system, memory management and virtualization, and a simple terminal interface if we have time. We would also like to output graphics to a monitor.
These are technical highlights of the hardware of the processor. First, we implement the open source RISC-V instruction set architecture. Second, we implement the different components needed for the CPU using VHDL or Verilog. These components include the control unit, the data path, the register file, the arithmetic logic unit, and the memory interface. The memory interface uses either the onboard memory blocks or an external RAM. Those memory interfaces are the instruction set, the instructions and data memory, as well as the cache. We will also be exploiting the FPGA for pipelining the instruction set architecture. Our stretch goals include the storage and I/O interface, peripheral and volatile storage, the graphics interface, HDMI or VGA, and the privilege mode instruction set architecture.
Technical highlights. Compiler. The compiler will convert C programs into RISC-V machine codes for our custom processor. The initial compiler will run on our development machine and will then load the programs onto the FPGA to be tested and run. Ideally, we want to create an improved compiler which will either run on the ARM cores in the Zinc processor and then compile C code which will then be run on the RISC-V processor, or make an editor and a compiler to run natively on the RISC-V processor. Stretch goal highlights. The operating system. The operating system uses the privilege level instructions on the custom processor. It runs with a terminal interface. It will schedule processes to be run on the processor. It gives programs file system access. It manages memory and does memory address virtualization. And it gives programs access to some C standard library functions.
Our schedule from November through January looks a little something like this. We're going to try to gain experience in programming FPGA boards. The members of this group are taking classes that help us learn about how to program the boards and develop circuits for them. We're going to complete any prerequisite deliverables during that time, and we're going to research our existing processor, operating system, and compiler designs that we're building off of. Our goal is going to be to define machine code commands and translate them to RISC-V. In January, we're going to outline the ISA for our processor and compiler. That involves defining the machine code specifications. We're going to start making the base components of the processor and start prototyping the compiler in its early stages. In February, we're going to turn in our senior design project abstract. We're also going to complete components of the processor, such as the state machine, ALU, MMU, and so on. We're going to begin building the pipeline for our processor as well. Along all this, we're creating a test environment for the compiler that lets us verify the generated machine code and make sure it matches the specifications required.
The schedule for March includes an interim report, and we're going to start integration, which ensures that compiled code works on the processor. Then we're going to start programming the OS design, which implements a C standard library, also implements memory management and a file system. Our schedule for April will include preparations for presentations and demos, which will consist of Capstone poster, our final product demo, and a Capstone video. We'll also be working on our stretch goals, which will be consisted of our operating system that manages multiple processes, and if time permits, will output graphics to a monitor.
From Harris, we would like to request guidance and mentorship, specifically on the topics of effective hardware design and timing, compiler development, and scope management for the project, given the time constraint. Additionally, we would like to request $1,200 for hardware powerful enough to fulfill our needs. The funds will be split such that $1,100 will be used to purchase a more powerful FPGA board than the school provides, allowing for a more ambitious project. The remaining $100 will be used to purchase PMODs for various digital outputs. To recap, our primary goals are to build a RISC-V processor and load the design on an FPGA board, program a compiler to write machine code from C, make an operating system, and run our operating system on the processor that we make. From Harris, we would like to request guidance in the topics of compiler development, processor timing, and project scope management. Additionally, we would like to request about $1,200 for our hardware needs.
Thank you for watching our presentation. We will look forward to working with you in the future.